Hi guys, today I'll be doing video notes for our chapter 4 practice test. So just to help you in case you're having trouble with any of the problems, you'll notice that all of the problems are 1A and 1B. So A's are the ones that I'm going to do, and you have to practice B's on your own, right? To make sure that you know how to do it. Same thing goes, if you get help from someone else on A, you have to try a problem on your own, because just because someone can talk you through the problem doesn't mean you understand what's going on, okay? So for 1A, how many solutions or total solutions are there? Well, hopefully you remember it has to do with the number of ups and downs. So we're going up 1, down 1, up again, right? So this is 1 solution, down, this is 2, and then up, this is 3. 3 total solutions. Non-repeated roots is solutions that are not repeated. Okay, so this is just, there's 1 of them, and then this one is a repeated root, so there's 2 of those. Okay, so those add up to 3. Let's take a look and keep going. So the leading coefficient is, and hopefully you remember that leading coefficient tells you where the graph is going on the right. And since it's going down, the leading coefficient is negative. Oops, sorry. Ooh, sorry about that. Definitely not positive, okay? And now we're going to write the specific equation of the graph in factored form. Here the thing is you have to find the a value, okay? So if I say specific, that means you have to find another point where it crosses through. So we do have x-intercepts, and then we have this extra point at 0, -3. Okay, so let's see. We have x-intercepts at x equals -4, x equals -2, x equals 1, and x equals 3. Which means that you're going to have y equals a, parentheses, x plus 4. Remember all the signs change. X plus 2, x minus 1, and x minus 3. We know our extra x and y values are going to be 0 and -3. So I'm going to plug in -3 for y. I don't know a because that's what I'm solving for. Let me copy everything down first. And then instead of all my x's, I'm going to put in zeros. And so at this point, all you're doing is simplifying your values, 0 plus 4. So it's a times 4 times 2 times -1 times -3 equals to -3. 4 times 2 is 8 times +3 is 24. Divide by 24 on both sides. And that gives me, I'm going to run out of space to write my actual equation, so I'm going to do it over here. A equals -1/8. Okay. And if you don't know how to simplify your fractions, please remember that you're going clear -3 divided by 24. And if you hit math fraction, that'll give you your reduced fraction that you're looking for. Final answer, you're going to take this a value and plug it into your first line. So we have y equals -1/8, which matches our negative leading coefficient. And then we have x plus 4, x plus 2, x minus 1, and x minus 3. That's our final answer. Sorry, guys. Now we're going to describe the degree and leading coefficient of the polynomial. Okay, so we know the leading coefficient is negative. I'll write it out. Leading coefficient is negative. Because the graph goes down on the right. Right here. Okay, so this is a negative leading coefficient. And then the degree is 3 because there are 3 ups and downs. Right, so 1, 2, 3. Okay. How many total real and imaginary solutions are there? Well, total solutions we talked about earlier was the same as your degree, right? So we go 1, 2, 3, 4, 5, 6. The number of real solutions, this one's a little tricky. Okay, so this is ups and downs. Real solutions, this looks like your x-intercepts, but you need to put in your repeated x-intercepts. So here we have 1, there's 2 here. I don't know these numbers, but I know there's like 1 here, because those are lines. This is a parabola, and parabola means there's 2 of them there. So there's 4 total real ones. That means our imaginary solutions is 2, because real plus imaginary equals your total. Okay? These always have to come in pairs because there's always a plus or minus I. So now if I give you factored form, how can you sketch the graph? Guys, when it says label the x-intercepts and y-intercepts, labeling does not mean there's a point there. Labeling means you put the number onto your graph. Okay, so this is x equals -3. So I'll put a -3 here. This is x equals -2, sign switch. And then this is x equals 3. Click here-ish. How do we find the y-intercept? Y-intercept is you plug in x equals 0. So let's do it. Not into these numbers, but the original ones, right? Don't forget your squared. So we have 3 times 2 times -3 squared, which is just 3 times 2 times -3 times -3. That'll be 6 times 9, which is 54. I know my leading coefficient is positive, so it goes up on the right. And I know that at x equals 3, this is a multiplicity of 2. That's a parabola. So I need to have a parabola there, which makes sense because look, I'm coming back to hit 54 on my my function. Okay, it's actually 1, 2, 3, 4, degree of 4. These ones have no exponents, so they're 1s, which means that they're lines. So I'm going to cross through for a line and cross through for a line and check that I have 1, 2, 3, 4. 1, 2, 3, 4. Okay, so now let's move on. We graphed this below, but there's a typo. There has to be. What's the mistake? So there's a few things you can look for. If I give you factored form, you could look for like the x-intercepts, right? But I didn't give you x-intercepts. But we can take a look at leading coefficient and degree. So my leading coefficient is positive, which looks good right now. And so degree, I can count 1, 2, 3, 4, but look, there's an exponent degree of 5. So the graph has 5 up, down slopes. So the degree is 5. The degree should be 4, which means the largest exponent should be 4. Do you guys see how I did more explanation than just the degree should be 4? If the degree is 4, then the largest exponent should be 4, not 5. Okay, so let's see if we have another mistake. This one is different. We can check degree. Let's see. 1, 2, 3. Okay, so there is a problem, and the degree should be 3. Let's see. We have solutions. Oh, sorry. The degree is 3 on the equation. It's asking how is my equation wrong? So the degree on the graph should be 4. So somewhere we're missing an extra one. Let's check our signs. -2 changed to +2. That looks great. This one is my 0. And then this one is +1 changes to -1. So my x-intercepts look really good. But we lost a parabola, right? We're missing a degree. So do you notice how there's like an upside down parabola here at x equals 0? Well, that means you need to have a a degree here of 2. Another thing I could check is my leading coefficient correct with a positive leading coefficient? And yes, I do have a positive value here. Okay. Let's see. If I need to multiply this out and put it into standard form, that means just multiply, right? So I'll do a box method. I'm big on box because it saves space. So I have x minus 1, and then x squared plus 3. That means I'll have x cubed minus 1x squared plus 3x minus 3. Okay, so I'm multiplying to get these numbers inside, and then I'll put it into standard form, which is y equals x cubed, biggest exponent first, then my next largest exponent, all the way down. Okay, so that's my standard form. Which makes it really helpful because that means my y-intercept equals -3. Okay, so make sure you read the problem because it asks for two things, standard form and the y-intercept. Okay, we're a third of the way through. Given the polynomial, show that x plus 1 is a factor. Well, if I'm giving you information, you should absolutely use it to do synthetic division. This means this is x equals -1. So I'm going to do synthetic division here. 1, x cubed, x squared, x's, and numbers. Okay, so 1, -8, +11, and 20. Let's just check my signs real quick. Okay. And we know the remainder should be 0. So we get 1, -1, -9, negative times a negative is a positive. Add it together. Okay. Let's find the solution to the polynomial now. So we know right away one of the solutions is x equals -1. Okay, I'm going to write that in before I forget because that happens all the time. There are 3 solutions total. And then what I have right now is 1x squared minus 9x plus 20. So I can factor this using my x method. Please write this out, right? And then just know from there that the -4 becomes a +4 and the -5 becomes a +5. These are solutions. Okay, what if I ask for factored form? This is where I lost some of you guys before. Okay. Factored form has to include everything your solutions do. Okay, so please keep in mind right here it says x plus 1 is a factor. And then we have x minus 4, x minus 5. This one seems pretty similar to what we were doing before. Total solutions is equal to the degree. So up 1, 2, 3. I also can look here at my exponent, right? My y-intercept, you can look at your graph here or right here. Y-intercept, y-intercept. Okay, so I'm going to find all the zeros. I have 2 of them already, but I know there's going to be 3. So I know x equals -2 is one of them. X equals 1 is another. And then I have a fraction. This is the one we don't know. That's the one I'm looking for here. So if I know 2 solutions, I probably should do synthetic division 2 times with those numbers, right? let's see, we have, first one is 2, -1, -7, and 6. And I'm going to put in x equals -2. Guys, if you don't get a remainder of 0, don't try to fudge your numbers to make it work. Go back and check your work to see if you can find the mistake. So this is 2, this was x cubed, right? So this is now x squared. But I'm going to do it again with x equals 1. So bring down the 2. 2 times 1 is 2. -5 plus 2 is -3. 1 times -3 is -3. And that 0 doesn't count. Like, we're not using that anymore. So here's my second remainder of 0. Well, this was 2x squared minus 5x plus 3. Now I have 2x minus 3 as what's left. That's a factor. Okay, so this is a factor. My other factors will be x minus 1 and x plus 2. Okay, that comes from these original ones. But how do we solve if we have a factor of 2x minus 3? Well, set it equal to 0 and solve for x. We get x equals 3 over 2. You do have to write all 3 of them, though, to show that you know that there are 3 solutions and you know what they are. Okay. Find the following. Total solutions. Up, down, up. There are 3 total. There's only one real solution. Okay, x equals 1 is my only real solution. That means I must have 2 imaginary ones over here that do not cross the x-intercept but still exist. So I'm going to use synthetic division. 2, 1, -1, -2, and x equals 1. Okay, so I have 2x squared plus 3x plus 2. Now, since I know it's imaginary, I don't even need to try factoring. It's not factorable. Okay, so there's 2 imaginary means not factorable. When it's not factorable, we use the quadratic formula. And we know x equals 1 is one of my solutions, right? Then we have x equals and x equals. Okay, so let's do the quadratic formula. X equals -b plus or minus, I might run out of space. I'll write it up here. b squared minus 4ac all over 2a. And let's start plugging in our numbers. So b is 3, so I have -3 plus or minus 3 squared minus 4 times 1 times, a is 2, sorry, 4 times 2 times 2. All over 2 times 2 for a. Okay, so let's simplify now. Negative parentheses 3 is just -3. 3 times 3 for 3 squared is 9 minus 4 times 2 times 2 is 4, so 4 times 4 is 16. All over 4, which gives me -3 plus or minus square root of -7 all over 4. Well, please remember that the negative becomes an I, right? And so your final answer will be -3 plus I root 7 over 4 and -3 minus I root 7 over 4. I don't know what the square root of 7 is, so I'm leaving it as the square root of 7. Now, number 12a, I'm not giving you any additional help. We know the y-intercept is -20. Okay. I don't know what any of the solutions are, which means I cannot do synthetic division. No solutions given. equals no synthetic. Okay, so that means I need to start from and do factoring. Okay, so let's see, x cubed plus 5x squared minus 4x minus 20. Anytime you see 4 terms, check if you can divide everything by anything. But notice there's a 1, so I cannot. That means I move on to double GCF. Remember that you're always canceling out the last term. Notice there's no x's here. That's why there's none down here. And then you need to cancel out the first positive or negative, right? This one was positive. That's why these are positives. Then your GCFs go outside the parentheses. And when you divide correctly and you chose the right GCF, you should get the same thing inside both parentheses. If you get something like a positive x here and a negative x here, it means your signs were wrong. Okay. We put GCF and GCF together, and then we put the x plus 5 together. If I distributed, I use x plus 5 2 times, but I don't need to write 2 times. Factor more. This is a difference of squares, which means subtracting a perfect square, which means I can break it down to positive 2 and negative 2. And we get x plus 2, x minus 2, and x plus 5. This is factored form. And then, it got really dark. If I want the solution, then you need to set each one equal to 0. So it'll be x equals negative 2, x equals 2, and x equals negative 5. Last page. Don't forget that there are a bunch of answers on the back for you to check as well, okay? So is x equals 2 a solution? Why or why not? Well, if it's a solution, then when you use synthetic division, then the remainder should be 0, right? So let's check. X equals 2. Don't change the signs. That's why I always write x equals over here. 1, x squared, x's, and then numbers, just to make sure I'm not missing a 0. Let's check. I bring down the 1. 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. And my remainder is 4. So x minus equals 2, x equals is not a solution because the remainder is not 0. Oops. So now let's go into writing equations. This is now 4.9. Any cubic equation means that we don't need an a value. Okay? No a needed. It means that we can have any a value you want. If it says specific, then you need to solve for a. Okay, so let's see. I've got y equals x. This is positive 1 as an x-intercept, so I'm going to subtract 1. X minus 3 and x plus 6. Okay, we don't know what a is. You can write a in as a habit if you want to, because that'll help you, but you can leave that as your final answer. Okay. Now we have this extra point, which is your x comma y, right? So we're going to take this and plug in 0, 54, and solve for a. So I'm going to write 54 equals a And you'll have 0, minus 1, 0, minus 3, and 0 plus 6. Put the zeros in after. And you can simplify. We've done this problem already. So we're going to have 54 equals a times negative 1, negative 3, and 6. That's 54 equals 18a. Negative times a negative is a positive, or check on your calculator. Divide by 18 on both sides. And you should get 3 equals a, which means your final equation is y equals 3. And we're going to go back to the very beginning and plug in to your equation. Okay, finite differences was our last topic. So this is the one where you have to find what it's changing by. And remember, direction matters. Okay, so if you tell me this is 16, it is, but it's getting smaller by 16, right? 30 to 20 is minus 10, minus 16. If you aren't able to do this in your head, remember it's your second number minus, that always has to be there, your first number. Okay, so in this case, I'll go negative 16 minus positive 4, which is negative 20. Negative 38 minus negative 16. Notice I put a double negative, which is negative 22. Negative 60 minus negative 38. Okay, so check your signs carefully. And then negative 80 minus negative 60. It's the second number minus the first number. Okay, so it's not linear. And then this, we'll keep going. This will be negative 6, negative 4, negative 2. From negative 22 to negative 22 is 0. And then positive 2 here. That's the one you want to be really, really careful of. Okay, students will mess up on that one. And then negative 4 minus negative 6 is positive 2. So we know the second one wasn't consistent, so it's not quadratic. And we're going to add 2, add 2, add 2, and add 2. So this is a cubic. Okay, let's check, did we do everything? Find the degree, so degree equals 3. Please make sure you write that. Then use your graphing calculator to write the equation. Okay, so now we have to go stat, and then edit. And we need to clear our list, not delete. Nothing happened to these numbers because you didn't hit enter. And then go up, clear, and then enter again. So I'm going to put in 1 through 7 for x's. 1, enter, 2, enter, 3, enter, 5, 6, 7. And then I'm going to go over to these numbers. 30, 20, enter, 4, enter, negative 16, negative 38, negative 60, and negative 80. Okay. Now I'm going to go stat, calc, and you have to pick the right one based on what you find, linear, quadratic, cubic, which is what we want. Hit enter until you see this, and you get y equals, it's cubic, r squared is 1, so that's 100% accurate. And you can just write your decimal, 0.33 x cubed plus, minus 5 x squared plus 2.67 x, and then plus 32. The notes for this are on page 100 on the back if you need the steps a little bit more clearly. Okay, last two things are transformations. So we're going to describe the transformations. This one is easy because it's a parent function. Okay, so this is the one where you technically don't have to write out each step. This one doesn't start as a parent, so write each step out. So you want to break down 1, 2, 3, 4 things are happening here. So there's a reflection on the outside, which is a reflection over the x-axis. If you don't know this, you probably want to check your notes, which was page 98, I think. Is that right? No, I think it's earlier. Look for 4.7 in your notes. Sorry, guys. I don't know off the top of my head. Okay, it has like the table with all the words. So that means I'll have a negative x to the 6, and then I'll have a vertical stretch of 2, because I'm multiplying by 2. Plus 3 has to turn to negative 3. So it's a translation, negative 3 left, and then positive 7 up. Okay, so far it looks like this doesn't matter. Plus 3 to the 6th power, and then negative 2x plus 3, 6 plus 7. Okay. So we did talk about this one where, like, if you start with a parent function, you technically don't need to show this because nothing happens. However, if you skip the steps here, then you're going to be messing up somewhere. Okay, so let's take a moment and we'll write down f of x equals x plus 1 cubed minus 6. Okay, now let's perform some transformations. We are going 4 units left. Well, when we go 4 left, it's x plus 4 inside, right? So that means to the inside values, I want to add 4. Or you can think of it as I replace my x with x plus 4. Just think of it that way. Let's do that. So I will have parentheses x plus 4 plus 1 cubed minus 6, right? You see how like this literally replaces your x value, okay? That simplifies to x plus 5 cubed minus 6. Then I'm going to go 3 up. That's f of x plus 3 at the end, right? So really what I'm doing is I'm taking the whole thing and then adding 3. So now I have x plus 5 cubed minus 6 plus 3 is minus 3. Then a vertical stretch. Vertical stretch of 2, and this is where I'm trying to trick you. There's a 2 in front, but you can't just slap the 2 in front. We're taking the whole thing, multiply by 2. So we need to distribute to this one and this one. So there's going to be a 2 in front of the x plus 5 cubed, but the negative 3 is also stretched by 2, which becomes negative 6. This equals to g of x. Okay, that concludes my A problems. It is now your turn to try to go back and complete the B problems on your own.